To draw polar equations, we first of all need to change the type of graph we have. Currently it's set at y equals. If I press OK and then the first option for type, we want to go to the second option, which allows us to enter in polar equations. For example, we could enter in the polar equation r equals cos theta. Remember, when we press this key, we load up theta. So if I draw this graph, here is the graph of r equals cos theta. Let us draw the graph of r equals a over cos theta. Let's input this into our calculator. We have r equals a over cos theta. Let's draw this graph, and if I press the tools key and the fourth option for modify, let's vary a and explore what happens. If a is equal to 1, we have a vertical line at x equals 1. When a equals 2, we have a vertical line at x equals 2. This also applies for the negative a's. For example, when a is equal to negative 3, we have a vertical line at x equals negative 3. In general, r equals a over cos theta gives us a vertical line at x equals a. Let's draw the graph of r equals a over sine theta. Let's input this into our calculator. We have r equals a over sine theta. Let's draw this graph. If I press the tools key and the fourth option for modify, let's vary a. When a equals 1, you see we have a horizontal line at y equals 1. When a equals 2, we have a horizontal line at y equals 2. And this also applies for negative values of a. For example, when a equals negative 2, we have a horizontal line at y equals negative 2. In general, r equals a over sine theta gives us a horizontal line at y equals a. Let's draw the graph of r equals a theta. Inputting this into our calculator, we have r equals a theta. Let's draw the graph. Before that, let's change the axis settings. Let's change the x minimum to be negative 25, the x maximum to be 25, the x scale to be 5, the y minimum to be negative 25, the y maximum to be 25, the y scale to be 5. Let's draw this graph. Let's press the tools key and the fourth option for modify, and let's vary a. You can see as we vary a, we end up with the spiral. Let's draw the graph of r equals a. Let's input this into our calculator. We have r equals a. Let's draw this graph. Let's change the x minimum to be negative 8, x maximum to be 8. We'll leave the x scale as 1. Let's change the y minimum to be negative 8, the y maximum to be 8, and the y scale let's leave as 1. Let's draw the graph. Let's press tools, the fourth option for modify, and let's vary a. Now, when a equals 1, you can see we've got a circle with centre at the origin and radius 1. When r equals 2, same thing. We've got the centre at the origin, but this time the radius is 2. And we can explore with that even further by varying a. In general, r equals a gives us a circle with radius A and centre at the origin. Let's draw the graph of r equals a cos theta plus b sin theta. Let's input this into our calculator. We have r equals a cos theta plus b sin theta. Let's draw this graph. Let's change the x minimum to be -8, the x maximum to be 8, the x scale will leave us 1, the y minimum, let's set that to be -8, the y maximum, let's set that equal to 8, the y scale will leave us 1. Let's draw this. If I press tools and the fourth option for modify, we can vary a and b. Now, varying a, let's see what happens. You can see here we've got a circle with the y coordinate of the centre lying along the x-axis. Let's make a 0. Let's make b 1. You can see here we've got a circle with the x coordinate of the centre lying along the y-axis. Now, let's change a to be 4. We have a circle with centre 2 across, 0 up. And the radius here is 2. Let's change b to be 3. We have a circle with centre 2, 1.5 and radius 5. In general, r equals a cos theta plus b sin theta gives us a circle with centre a over 2, b over 2 and radius the square root of a squared plus b squared. Let's draw the curve r equals a cos n theta. Inputting this into our calculator, we have r equals a cos n theta. Let's draw this graph. Now, if I press the tools key and the fourth option for modify, let's vary a. So far, when we vary a with n equaling 0, we have a circle. Now, let's let n equal 1. Here we've got a circle. When n is 2, we end up with a rose petal. When n is 3, we still have a rose petal, and we can explore that by varying n. Now, you will notice when n is an odd number, we have n petals. However, when n is an even number, we have 2n petals. And you will also notice the radius is equal to a. In general, r equals a cos n theta gives us a rose petal curve where n is greater than or equal to 2. When n is even, we have 2n petals. When n is odd, we have n petals. Let's draw the curve r equals a sin n theta. Let's input this into our calculator. We have r equals a sin n theta. Let's draw this graph. If I press the tools key and the fourth option for modify, we can vary a and n. You can see when I increase a, so far nothing is happening, and that's because we've got the sign of 0. Let's change n to equal 1. Now let's vary a. Here you can see we've got a circle. Let's increase n to be 2. what you can see now is we have a rose petal. And as we vary n, you can see the effect of varying n. Now, you will notice when n is odd, we have n petals. However, when n is even, we have 2n petals. In general, r equals a sine n theta gives us a rose petal curve with radius a where n is greater than or equal to 2. When n is odd, we have n petals. When n is even, we have 2n petals. Let us draw the graph of r equals a plus minus b cos theta, where a and b are both greater than 0. This type of graph is called a limacon. Let's input this into our calculator. We have r equals a plus b cos theta. Let's draw this graph. Let's press the tools key, the fourth option for modify. Let's vary a and b. Now so far we know that a and b both have to be greater than 0. So let's change those accordingly. Now, in the case where b is greater than a, such as what we see here, you can see we've got a limacon with a loop. What would happen if a is equal to b? For example, a equals 2, b equals 2. Well, here we've got a cardioid, and notice the distance from the y-axis to this point here is twice a, and the distance from the x-axis to here is a. What would happen if we had a being greater than b? For example, a being 3 and b being 2. Well, in this case, you can see we've got a dimple. What would happen if a is greater than or equal to 2b? For example, a is 2 and b is 1. Here we have something which is convex, and notice this bit is flat. Let's draw the graph of r equals a plus minus b sine theta, where a and b are both greater than 0. This type of graph is called a limacon. Let's input this into our calculator. We have a plus b sine theta. Let's draw this graph. Let's press the tools key and the fourth option for modify. We know so far a and b have to be greater than 0, so let's change a to be 1 and b to be 1. Now, in the case where b is greater than a, so for example, b equaling 2 and a equaling 1, you can see we've got a loop. In the case where a and b are both equal to each other, for example, a equaling 2 and b equaling 2, we have a cardioid. In the case where a is greater than b, so for example, a is 3 and b is 2, you can see here we've got a dimple. In the case where a is greater than or equal to 2b, for example, a is 2 and b is 1, we have something which is convex, and notice here this portion is flat. Let us draw the graph of r equals the square root of a squared cos 2 theta. This is known as a lemniscate curve. Let's input this into our calculator. We have r equals the square root of a squared multiplied by cos 2 theta. Let's draw this graph. If I press the tools key and the fourth option for modify, let's vary a. You can see we have a loop as such, and the radius of this is a. Let's draw the graph of r equals the square root of a squared sine 2 theta. This type of curve is known as lemniscate. Let's input this into our calculator. We have r equals the square root of a squared multiplied by sine 2 theta. Let's draw the graph. Let's press the tools key, the fourth option for modify, and let's vary a, as we see here. What you see is we have a radius of a. In general, r equals the square root of a squared sine 2 theta has a loop with its radius being a.